Welcome back. So we're now at Unit 1, Lesson 2. And if you're looking for a title for your notes, you can call this Strategies for Finding X, or Strategies to Find X is kind of what I'm calling it on the video. It's a little shorter. Let's talk about what we've been discussing in class. We've spent almost a week working on factoring. So we've had blocks and no blocks and quadratic expressions that have really simple terms, really complicated terms, but at no point along the way have we really discussed why any of this is important. So if you've been asking yourself, why does this even matter? You came to the right video, because that is what we need to talk about next. Of course, if I say algebra to just about anyone, the first thing that people think about is the fact that it is the class where you learn how to find x. In fact, I'm pretty sure there are plenty of memes out there that make jokes about that. Let me give you an example of a really simple problem. 3x plus 5 equals 2. When we are in algebra, we care about finding x, and so we have these strategies. So let's say, what color do I want to use here? We'll use yellow. Okay, so I'm trying to find x. This is what I want. In order to do that, I need to get it by itself. The first thing we do is we kind of work from the outside in. So we move the 5 away first. I know you know how to do this, but let's just pretend that we don't. That would leave us with 3x equals negative 3, and of course x therefore must be negative 3 divided by 3, so the answer is negative 1. So the solution is x equals negative 1, and that is algebra. Right? So what we did in Algebra 1, for those of you who have taken geometry, we did it in geometry, and we will be doing it again in Algebra 2. But what happens in mathematics, and this isn't just about a high school math course, but just mathematics in general, is that the further you get in, the more complicated the problems are that you have to solve. And not complicated like, you know, the textbook company just decided to make harder problems to make your life more difficult. Mathematics is about finding basic tools that we can apply in many different circumstances, so that when we're faced with a brand new problem that we've never seen before, we can go into our little math toolbox and open it up and say, oh, what are the tools I have to figure out what a missing x is, or to figure out something else. There's many different aspects of algebra, but certainly finding x is a big one, or a variable in general. It doesn't have to be x. This is even what mathematicians at much, much higher levels than high school have to do. There are unknowns that they need to discover. There are physics equations that have yet to really be completely formulated. And how do they do it? Well, they go into their toolbox of strategies that they have learned before, and they try and try and try until they find the one that works. And so here we are in a high school Algebra 2 class, and we're doing the same thing. But I will assure you that there are many more strategies available out there than what you've already learned in Algebra 1. In fact, that's why there's an Algebra 2 course. And you may see this coming here, because let me show you an example of a problem that's much more difficult as far as x goes, but might look familiar as far as how it compares to things we've done in class. So we've been talking about quadratic expressions. Now, an expression is a quadratic, so it has like an x squared. I'm just going to write this. This has nothing to do with what's in blue. But a quadratic expression would be something like x squared plus 5x minus 6. So no equal sign. An expression just states something mathematically, but it doesn't make it equivalent to anything. It can't be solved. We can move the numbers around. I can make it x squared minus 6 plus 5x. I could make it negative 6 plus x squared plus 5x. I can move things around. I could try to put it into factored form, which I may or may not be able to do, but I can't solve it. There's no equal sign. I can't say, let's isolate x, let's get it by itself. That's a mathematical expression. I'm going to just clear and rewrite. This, on the other hand, is not a mathematic expression, it is a mathematical equation. So I'm going to write the word equation just because I want you to see that we almost have the word equal in it. And the reason that's important is because I want you to remember, not because you need to write it down in your notes, but I want you to remember if I say expression, there's no equal in that word. So there's no equal sign in a mathematical expression. But if I say let's make an equation, the first thing you should think of is equations have equal signs. And so let's go back. There's our equation. All right. How many times can I rewrite the same equation? I guess we're going to find out. So once we have an equal sign, we now know that it's possible to solve it. Or I shouldn't say it's definitely possible, but there's a good chance that I might be able to get x by itself. But now I have a different problem. Contrary to this example over here, 3x plus 5 equals 2, where I was able to very easily get x by itself, I have a problem on this one because there's an x over here. It's an x squared. There's an x over here. I can't combine them because they're not like terms. But I can't really get just one of them by itself. Like right now I have x squared by itself. I could try to undo the square and I don't know, take the square root of both sides, something crazy like that. But it would still give me x equals something that has another x in it. That's not going to give me an answer. That's going to be a bit of a problem. And so I find that when I'm facing a quadratic equation, it's pretty easy to get stuck. And so somewhere along the line, there was a very smart mathematician who was looking at a problem like this and thinking, there must be a way that we can get around this problem and we can figure out how to solve for x. There's got to be a way to get x by itself. And sure enough, they stumbled upon a truth, a mathematical truth, that we are going to call the zero product property. Now, the zero product property is not very exciting. In fact, it's really obvious. But as far as mathematics strategies go just in general, we often find that the most obvious things are the most helpful. So here's the zero product property in summary. It says if I have two different numbers, so A and B, let's assume that they're mystery numbers. We don't know what they are, but we know that they have a numeric value. And if they're being multiplied and they equal 0, then there's something that I automatically know about either A or B. So I don't know what A is, I don't know what B is. All I know is that A times B is 0. Well, that automatically means something to us. And think for a second about what that might be. A times B is 0. What does that mean about A and B? This is me pausing to let you think. All right, I'm going to give it away. If you need more time to think, you can pause the video. Here's the key. If A times B is 0, then either A is 0 or B is 0. It's the only way to get a 0. The only way to get 0 when you're multiplying is for one of these two numbers to be 0. Either it's 0 times B or it's A times 0. That's the only way that we can get 0, and that is the zero product property. Pretty straightforward. Not the most earth-shattering thing you've probably ever heard. But believe it or not, that is the key to how we're going to solve these complicated quadratic equations. So keep in mind that 0 is important, and let me show you how this is going to help us. Well, right now I have x squared equals 5x minus 6. I don't see a 0. I'm telling you 0 is going to be important, but I don't see a 0. But I'm going to create a 0, and here's how I'll do it. I'm going to move everything over to one side. Now, it doesn't matter which side. I can move everything to the left, or I can move everything to the right. Either way, I'm going to move it to the left because I like it that way better. So I'm going to move 5x over. How do I move 5x? I subtract 5x. That's going to get it over here and get rid of it on the right. And how do I get negative 6 over there? I add 6 to both sides. That will get rid of it on the right, move it to the left, which leaves nothing on the right. Just in case for those of you who feel like it's been too long over the summer to remember what I just did, here's the steps in between. I just said minus 5x on the left, or minus 5x on the right, do it also to the left. Add 6 to the right, Also add 6 to the left. This is how we get, oops, sorry, as I cross out my numbers. This is how we get this on the left, and it's also how we get nothing on the right. Okay, that's nice. Now I have a 0, but I don't know what you're thinking, but the x's still can't be isolated. They can't be brought to be by themselves, so I can't solve for them. But we've been learning in class that this is not the only way that I can write many quadratic expressions. In fact, I could write this in factored form. For those of you who have quickly already done it in your head, you probably can fill this in already. If you haven't done it in your head, you can take a moment to pause the video and see if you can figure it out. But I'm going to tell you, this factors to be x minus 2 times x minus 3. Those are the dimensions of the rectangle that would have these parts in it. X squared, 5 negative x's, 6 1's. So these are equivalent expressions. They look different, but they mean the same thing. Okay, this is where things get interesting, because look what I have created now. I've actually created an expression that involves multiplication of 2 pieces, right? That's kind of the idea of length times width of the rectangle. This is an expression, x minus 2, times, this is another expression, x minus 3. This should look a little bit like our zero product property. Something times something else equals 0. Again, something times something else equals 0. Well, what does this mean? Well, it means that in order for this expression to equal 0, either a is 0, this is like our a, or b is 0. One of them has to equal 0. So either x minus 2 is 0, or x minus 3 is 0. One of those has to be true. Let me just put that on a new sheet here. So x minus 2 is 0, or x minus 3 is 0. It's the only way for our expression to come up with a solution of 0. How is that helpful? Well, actually, it's very helpful because I've now created 2 different equations where there's just one x. One x. So that means I can add 2. So this expression could be simplified down to x equals 2. And this expression could be simplified down to x equals 3, which just so happen to be the 2 possible solutions to x. Let me show you what I mean by that. Let's go back here. We just said that either x equals 2 is an answer, or x equals 3 is an answer. And that might make sense already down for this part, but let's go back to our original equation, which is x squared equals 5x minus 6. Let's write it here because I just don't want you to have too much crammed into one sheet. So our original was x squared equals 5x minus 6. Let's try plugging 2 into that equation. On the left, we get 2 squared, that would be 4. And on the right, we would say 5 times 2 is 10, minus 6 is 4. 4 equals 4. It worked. That's pretty cool. So 2 is a possible solution to our original equation. Let's try it with 3. Plug it in. 3 squared is 9. That's on the left side, right? We're doing like left and right. On the right side, we have 5 times 3, so that would be 15, minus 6. 15 minus 6 is 9. 9 equals 9. It worked. 3 is a solution to our original equation. So what we were able to do is, here was our basic equation. We over here where we learn how to just get x by itself and we figure out what x needs to be in our original equation, what would make it true. We say in algebra, what makes it true? Well, now we've found a different strategy. It's a little more complicated. It has more steps, but we found a way to figure out what x is in a very complicated equation. In fact, now I'm making this just look scary, right? Okay, let's just do a quick review before, I'm just going to erase this, before we end this video. Those of you who like steps, let's review. The first thing we did is we said the important key to this solution is to get 0 somehow into the equation. The way we do that is we move everything to one side. So step 1, if you want to write this down, feel free. I don't really have enough room to just write it out, but feel free. Oops, that's plus. Step 1 is right here. Get 0 into the equation. Step 2 is factor. Take the left side and put it in its factored form. That's step 2. Step 3 is to make equations where each part equals 0. In case you're like, what? Why did we do that again? Oh yeah, that's because of the zero product property. If I know A times B is 0, then either A is 0 or B is 0. That's what we did in step 3. So step 3 is to turn them into two expressions that equal 0. So this is step 3. X minus 2 is 0, x minus 3 is 0. And then step 4 is just to solve those two. There's basically two parts. Solve it here, x must equal 2. Solve it here, x must equal 3. And now you've finished. You're done. So step 1 is get 0 into your equation, make it equal 0. Step 2 is factor. Step 3 is to break it into parts because now you have a equals 0 or b equals 0. And step 4 is just solve those parts, and that's your answer. All right, we'll talk more about this in class. We'll work on some example problems. But basically what we've just done is we've taken your math toolbox and we've added a new strategy, which is going to allow you to solve new kinds of problems. If you've already done this before, which I'm not sure depending on your background if you have or have not, this is not where it ends. There's actually further applications to this throughout Algebra 2 and beyond. But this is kind of level 1 of using factoring to our advantage. So that is that. I hope you enjoyed your lesson 2 video, and I will see you in class.